Dashni Murugan, and I'm going to present about introduction and theory about distillation column. Distillation columns are one of the most often used type of separation equipment in industry. Distillation is one of the most common liquid-liquid separation processes that can be carried out in continuous or batch system. Distillation works by the application of removal of heat to exploit differences in relative volatility. The heat causes components with lower boiling points and higher volatility to be vaporized, leaving less volatile components as liquids. Mixtures with high relative volatilities are easier to separate. This makes separation of close boiling and azeotropic feeds difficult. So special distillation techniques have to be used to separate these mixtures. Distillation can be used to separate binary or multiple component mixtures. Many variables such as column pressure, temperature, size, and diameter are determined by the properties of feed and the desired products. Some specialized columns perform other functions such as reactive distillation columns, which combine reaction and separation of products into a single unit. An analyzation of a distillation column can be done easily by Aspenysis software or other software that is available in the market.
Hi, I'm Haja, and I'll be explaining step by step on how to run the high-shift program based on the case study given.
The first thing that you have to do is to add the component list. The component that we use based on the case study are acetone and acetic acid. After that, go to the fluid package tab and choose Entine as the fluid package. And then go to the simulation tab and write the material stream. Double-click at the material stream and fill in all the information for the material stream. The stream name should be feed. The temperature is 67.5 degrees Celsius, 180 ml for the pressure, and 100 pound-mole per hour for the molar flow. The next thing you have to do is to fill in the composition. The mole fraction for acetone is 65% and for acetic acid is 35%. The next thing you have to do is to drag the distillation column. And then double click at the distillation column and rename all the stream name. The stream name should be condenser, overhead, boil up, and bottom. At the inlet stream, choose feed as the stream. And then plug in the pressure value for your boiler and condenser. 180 ml for the condenser pressure and also 180 ml for the reboiler pressure. The next thing is to fill in the liquid rate. The liquid rate is 60 pound-mole per hour and the reflux ratio is 3. Now we have done with the stimulation steps. The last thing to do is to reset and run the program. At the design window, the information that you can get is the condition of the inlet and outlet stream. You can also get properties of the inlet and outlet stream. Another information is composition of the inlet and outlet stream. Finally, this is how our process flow diagram looks like. We have one inlet stream which is feed, and two outlet streams which are condenser and bottom.
Hello and hi, I'm Akila and I will explain question 2, investigate the effect on the top and bottom composition and energy requirements. Alright, as you can see on the table, there's number of stages. We have chosen 5, 10, 15, 20 and 25 for the number of stages and the composition of acetone, composition of acetic acid and energy requirements. Okay, next. Okay, as you can see, the graph composition of acetone vs number of stages. As the number of stages increases, the composition of acetone for both overhead and bottom product remain constant. And next, same goes with composition of acetic acid. As the number of stages increases, the composition of overhead and bottom product for acetic acid also remain constant. And next. And for the energy requirements for condenser and boil up is decreasing. I mean, as the number of stages increase, then the energy requirement decreasing. Okay, next. Okay, next is for second questions, reflux ratio. We have chosen 3, 6, 9, 12 and 15 and same as before, composition of acetone, composition of acetic acid and energy requirements. Next. Okay, this is the graph. As you can see, it's same as before. Means that as the reflux ratio increase, the composition of acetone for overhead and bottom product is also remain constant. Next. And same also, it's same for composition of acetic acid. Means that overhead and bottom product is remain constant as the number of reflux ratio increasing. And it's slightly different for energy requirements vs reflux ratio. As the number of reflux ratio increase, the energy requirement also increase, same for condenser and boil up. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan Ashraf bin Ibrahim. Today I want to explain about the stage efficiency and the composition of acetone and acetic acid. As we can see, we have chosen the stage efficiency 0.2, 0.4 and 0.6, 0.8 and 1. So below we can see the graph of the composition of acetone vs the stage efficiency. For the blue one is for the top composition and the red one is bottom composition. As we can see, for increasing stage efficiency, the composition of acetone is remain constant. For the composition of acetic acid is still the same as the graph for the composition of acetone. Just same. So next. And next I will explain about the feed stage and the composition of the acetone and acetic acid. For the feed stage, we also have chosen 5 feed stage. That is 5, 6, 7, 8 and 9. So based on this graph, increasing of the feed stage, the composition of acetone is still the same. This is for the top one, this is for the bottom, or we can see overhead. And for the composition of acetic acid, increasing feed stage, the composition of acetic acid is still constant. It's just the same. And energy requirement vs feed stage, we can see that this graph, this is decreasing. This is for bottom part, increasing feed stage. For this part, this decreasing and increasing back. And for the condenser, it will increase and decrease. That's it.
Hi, I'm Zahir, so I'll be doing the conclusion. So basically, this report has discussed the process of separating a mixture of substances which consists of acetone and acetic acid via a distillation column. The objectives of this lab session were to develop the necessary process units which are required to observe the temperatures, pressures and energy requirements, as well as indicate whether any changes would affect these readings. Both objectives of this session were met. By manipulating variables such as the number of stages, the reflux ratios and the stage efficiency, the simulation produced in the HASIS software was able to develop a set of data which correspond to the changes applied. This lab also introduced us to the important topics included in the principle of chemical engineering syllabus. We were able to utilize basic concepts applied in the field of chemical engineering such as mass balance and energy balance calculation, which were made easier using the HASIS software. The process units used in the software also allowed us to further develop our understanding of the mechanism involved in the simulation of distillation and condensation.
지겨워 always 왜 맘에 없는 남자만 말을 꺼내요 go away 에이 너무 뻔하잖아 식상한 매력 느끼한 말투 아무 느낌 없어 no no 제발 내 앞에 나타나줘 어디에 있나요 my love 날 구해줘
You're looking for a man that's realer 날 만나기 전에 맘껏 즐겨 인사에 자꾸 목적이 뻔한 남자들의 DM 알림은 다 무시해